We are an organization called BAJA SA. We compete in a collegiate design competition where we are given the challenge of designing, building, promoting, and racing a prototype single-seat off-road vehicle. That's a task we're given. How you go about that task is then up to the teams. How you interpret the challenge can be done in an infinite number of ways, and the way we view the optimal solution to this task is what we present as Chassis 43.
When we began the design phase, we laid out intents, and some of these intents were weight of the vehicle. We wanted to reduce the weight. Obviously, our previous vehicle, Chassis 42, weighed in upwards of around 600 pounds. We wanted to get that down at least 450 for this car.
We tried to optimize between two vehicles. We had 41 around, an old Chassis 41 and Chassis 42. So we actually had two vehicles we could weigh pros and cons with in every part of the car, actually.
We kind of started designing the frame and all the components early May. We started really over the summer. It's kind of difficult. We were all doing classes, working.
What we were able to do with the design is actually we split it up, front half of the car, rear half of the car. And what we would have is these meetings where we'd actually join the parties. Everyone would bring their part models, their latest revisions, and we would join the parts together, which would actually let everyone see where everyone else's subsystem was in relation to each other and how we had to modify and coax everything into place to be able to get everything to fit together in a final model, in a final vehicle design.
We were actually able to analyze the suspension motion using this Excel program.
In school, you're taught how to, let's say, know the stresses on a beam element, but how do you design a complex weight-reduced web design on a gear? You simply can't. So you have to rely on finite element method, and that's really where an FEA software package helps you out. We can identify and cut weight on special interest areas.
We were ready for manufacturing of the vehicle starting right after winter break. I mean, we started making the firewall like the first week in January, and I'd say it took us about a month to get it all fully tacked together. Maybe not fully welded.
You then way off. You had no, it was 47.59 we had an inch.
So some things we did to kind of cut our costs down and our machine time down is we had all the tubes sent out to a local company where they were CNC coped and then CNC bent. And then most of the copes were almost exactly where they needed to be. And that allowed us to, again, with the CNC cut jigs that we had, having the copes within a very tight tolerance kept our overall tolerance stack low. So when we put the jigs in place, and we put the tubes in place, everything actually fit the way it was supposed to, which definitely helped make the manufacturing process of the car go as fast as it did.
We had a lot of students in machine shops late at night, or and even during the day, they'd sit down and learn how the machine would work and learn from the machinists how to use the machines. And we had sponsors help out with manufacturing, whether it was laser cutting and whatnot.
One of the new processes we introduced into the composite team was called RTM, or resin transfer molding. How you utilize different types of carbon fibers, different weaves, different layouts, along with other materials such as Kevlar or carbon Kevlar hybrids to make the safest and lightest seat possible is something that we've gotten into. After the air is eliminated and everything is sealed as well as you want, then you introduce the resin under complete vacuum. It flows through the part and it comes out basically a flawless piece if you have everything sealed. The Baja season concludes at the end of the school year with 3 international events. There are usually 100+ teams from all over the world. Teams from the United States, Canada, South America, India can come to any one of these 3 events. This year, the UW Milwaukee team chose the Wisconsin event. The event is 4 days long. Each vehicle that's brought to competition is heavily scrutinized. Every part of the vehicle, every system on the vehicle, literally every nut and bolt is looked at, mainly from a safety standpoint, but also from a design standpoint. That's done by Honda engineers, and they'll look at the vehicle as the same people that design ATVs. The dynamic events include a mud bog, a sled pull, an acceleration run, a maneuverability track, and a suspension and traction event, it's called. And you score points based on how you do relative to every other competitor on each event, and then those scores are added to your total score, along with a score you receive for the cost of your vehicle and how your vehicle was designed. The final event, which is the largest event, is the endurance event. It's a 4-hour endurance race with all 100+ cars racing at the exact same time. It includes speed, but it also includes durability. If your car will make it, you have a good chance of finishing well. It really makes you optimize the car for not only lightweight and top speed, but also durability and longevity. Will your components last, and will your system stand up as a whole? Our endurance event was promising. We had promising speed, we had good maneuverability, we jumped extremely well. Some problems we did run into during the endurance event. Our front spindle, the shaft that holds the hub on, that broke off at a weld. How we fixed that was we re-welded the spindle back on using a little more material, a little stronger welds. That held up pretty well. We also had problems. We dented a rim, and we had to come in and just do a quick tire change. That was due to some pretty large rock obstacles that were part of the track. And then we also flipped the vehicle during the endurance event, ended up on its back end and kind of rolled over. When you flip, you have to get your frame inspected, which takes time. In the final hour, we had a problem with our new custom gearbox. What had happened is we had basically blown a bearing inside the gearbox. The gearbox ended up failing due to stripped teeth, which at the end ended our race and ended our weekend. This year, especially this team, in the years that I've been around it, is probably one of the most passionate teams, and one of the most dedicated teams, and probably has the most number of members involved. And I think you look at the process from, you know, the core designers of the car, and you extrapolate that into what has to happen to get this car to be a reality. And I think you look at everyone involved, you know, from the newest members to the oldest members, from the people with the most design experience to the people just learning. You really have to include everyone in that effort to get the car done. And I think without everyone pitching in as much as they did, without the sponsor help, without the faculty support, it just wouldn't be where it is today. And I think that's a tribute to this team and everyone's hard work.